Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.1, Problem 10. This is Problem 10 from Section 2.1. Solve the system of linear equations 3x minus 2y equals negative 3 and 5x minus y equals 2. So to start, we want to multiply one or both equations times some value so that one of the variables will have the same number in front but with opposite signs. Our options are, we could make a negative 15x and a positive 15x, that would work, or a negative 2y and a positive 2y, that would also work. It would give us the same answer either way, and it would seem to me that the y's are a little easier to cancel with the x's. So for that reason, I'll cancel the y. So I'll leave the top equation with a negative 2y, and I'll make this turn into a positive 2y. So the top equation can stay, and I will have 3x minus 2y equals negative 3. Now the bottom equation, in order to make this into a positive 2, I have to multiply not only times 2, but times negative 2 to make that become a positive 2y. So everything will be times negative 2. Negative 2 times 5x is negative 10x. Negative 2 times negative y is positive 2y. The negative times the negative cancels, positive 2y. And then negative 2 times positive 2 on the right side of the equals will make negative 4. So now step 1 is complete. One of my variables has the same number in front but with opposite signs. I have a negative 2y and a positive 2y. So step 2 is add the equations together in order to cancel one of the variables. So 3x and negative 10x will make negative 7x. The negative 2y, positive 2y will cancel. And then on the right side of the equal signs, I have negative 3 and negative 4 is negative 7. So that's step 2. I added the equations together and I canceled one of the variables, namely the y. Step 3, solve for the remaining variable. So if negative 7x equals negative 7, divide out the negative 7. You get negative 7 divided by negative 7, and x will be positive 1. The 7's cancel, the negatives cancel. That's the result for step 3. Step 4 is take your answer from step 3, put it back into either of the original equations, and solve for the other variable. Now, it's the same amount of work. You'll get the same answer. I'll pick the bottom equation for no special reason. I'll take 5x minus y equals 2. And now if x is 1, 5 times 1 minus y equals 2. 5 times 1 is 5. So 5 minus y equals 2. Now I want to get the y by itself, so let's get rid of the 5. So on the left side of the equation, we're going to do negative 5. On the right side, we'll do negative 5. So on the left, the positive 5, negative 5 cancels, leaving me with negative y. Don't forget the negative. Equals, on the right, positive 2 and negative 5 is negative 3. Now that's what negative y equals. I want to know what y equals. So I have to cancel the negative in front of the y. So we can basically do both sides divide by negative 1, if you want to think of it that way. Negative y divided by negative 1 equals negative 3 divided by negative 1. And you'll get y equals positive 3. So now x is positive 1, y is positive 3. That's the solution to this system of linear equations. And if you prefer to write it as a point of intersection, like if you drew the graph, these two lines would intersect at the point positive 1 for the x-coordinate and positive 3 for the y-coordinate. So x is 1, y is 3 will make both equations true at the same time.